Right, we're on the normal distribution tab down here. And a normal distribution is a typical bell curve shaped distribution, and it's bell-shaped, it's symmetrical. What's happening on one side is exactly the same with the other, mirror image. It's asymptotic, which means that it comes close to the x-axis or 0, but never quite reaches it. And the center is determined by the mean, or the average. The mean is where the center is, the standard deviation is how wide the data is. So you can have an infinite number of distributions based on where the mean is and the standard deviations. However, because of these characteristics, the probabilities can be created and have been tableized to speed up discovery and finding the answers. Okay. So a z-value is a set of predetermined probabilities. So you find a z-score based on your mean and your standard deviation. You look it up in the table of your statistics textbook, and it'll give you the probability based on that z-value. The z-value is x minus mu divided by the standard deviation, where x is the point on the curve that you're interested in, mu is the center or the middle point, and the standard deviation is standard deviation for the curve. Okay, so let's go into an example. The yearly income of a small community is normally distributed with a mean of 75 and a standard deviation of 5, where all units are in thousands, so 75,000 for the mean, 5,000 for the standard deviation. So we have 4 questions here. Number 1, what is the probability of making more than 85,000? Number 2, what is the probability of making between 75 and 80,000? What is the probability of making between 70 and 80,000? What is the probability of making lower than 65,000? So 4 scenarios, 4 problems. To begin with any of these problems, I'd like to start off with a drawing of some kind. So that's exactly what I'm going to do. I have a drawing here where the mean is 75,000. And the first question is saying, what is the probability of making more than 85? Okay, so I'm going to draw over here and I'm going to say, well, this is going to be my 85 point. Doesn't have to be fancy, doesn't have to be anything too whiz bang. I just want to know what's happening on the small end. And remember, it's going to be a small probability because we're saying more than 85, so it's going to be from this point up, not this whole big area over here. Okay, so that's going to be important when we finally start getting some of our answers. So we draw it out, we kind of get an idea of what's going on and say, okay, let's actually do some crunching here. So we go to our add-ins, Megastat, our probability. In this case, it's going to be the continuous probability distribution. Now we're going to have normal probability, we have t distributions, f distributions, and chi-square distributions. We're mainly going to be interested in the normal distribution. And I'm going to go ahead and clear it out here. So we want 85, the mean is going to be 75, and my standard deviation 5. And we can do a quick little preview. And we know right off the bat that we want a very small area, so this lower one doesn't make any sense. That's basically saying a 97% chance, almost 98. That doesn't go well with our little drawing here. That would be 97, 98%. We want the small little end over here. So it's going to be the upper value, or 0.228. So we push OK. And it gives us that information, gives us a z-score. So if we want to check our work, we can check it in a textbook. And it gives us our upper and our lower probability values. So in answer to number 1, we have about a 2% chance of finding someone that is making $85,000 or more a year. All right, so let's take a look at number 2. What is the probability of making between 75 and 80,000? Okay, I'm going to go back here rid of this here. So 80, between 75 and 80. Well, we know 75 is right here. So we'll say 80 is going to be about here. And we want to know this little area, or well, this larger area over here. Okay. And doesn't have to be too terribly fancy. We just want a visual of what's going on here. So this is going to be a little bit more complicated because remember the scores are going to tell you what upper and end, so it's going to tell you either this or the entire thing up to this point. Now remember, all the probabilities have to equal 1, and it's symmetrical on both sides. It's going to be very important for this problem because what's going to happen is we're going to find the probability of this whole area, and then we're going to minus this section over here to get the remaining area between it. So let's start plugging numbers in. So again, going to my megastat probability, continuous probability distribution. All this changes, all of that stays the same. I'm only going to be changing the 80. And I push OK. And that gives me an upper bound of 0.587 and a lower of 8413. So basically what I want is this lower one. Because basically what it's saying is, let me change the color here, all of this information is 84%. So I'm going to take that 84 8413, and then I'm going to take 0.5. Because what we don't want is this area over here. What we want is just this. So this area from this point over, since this is the middle, is going to be 0.5 or 50%. So just to reiterate, I have my larger value, which is that whole section, minus 0.5, which is this half taken out. So that leaves me with this small section here. So equals this minus this, and enter, which gives me 34.13%. So that'll be our answer for our next one, 34.13% probability chance of selecting somebody who is between 75 and 80. All right, on to number 3. What is the probability of making between $70,000 and $80,000? Okay, so let me get rid of this stuff here. So we have the 80, that's good. We want our 75, our 70 as well. We want this whole area. Okay, so we're going to do a similar technique where we're going to say, okay, well, we know that we're going to have an upper and a lower bound. So I'm going to take this whole lower bound, it's going to be a pretty big number, minus the lower bound over here, which gives us, mixed in together, the section that we're really looking for, this area. So it's kind of a mess, but just to reiterate, we're going to get the number for this one. Oops, let's do that blue. We're going to then minus this section over here, which hopefully leaves us with this area right here. Okay. We're going to have to do this twice. So probability, continuous probability distribution. We have the 80 already in there. So let's put in 70. Okay. Okay, so we have the upper bound for our 80. So 8413. Don't forget to put the decimal. We have our lower bound for our other portion, 0.1587, and we're going to minus this from this. So this is that little section that we don't want. This is that whole area, and minus it, we're going to get what we want, which gives us 0.6826, which actually makes a lot of sense because if you remember the empirical rule, plus or minus, well, one standard deviation from the mean is 68%. The mean is 75, plus 5 would be 80, minus 5 would be 70. So we really didn't have to go through all that work if we understood the empirical rule, but it's good practice nevertheless, and it proves that the empirical rule does work based on these certain sets of circumstances. All right, the last one is, what is the probability of making lower than 65? Okay, so let me get rid of all these. So we're going to be looking at a lower boundary, 65 here, and something like that. It's going to be a small sliver over here. Again, going to our megastat, probability, continuous probability distributions, 65. And looks like 0.2%, or 2.28%. Okay. So again, yeah, very small probability of this happening. All right. Another thing that should be taken into account is, well, what if I get a negative number? Well, just take the absolute value of it if you're doing it by hand, because it is symmetrical. What happens on the left side is exactly the same as on the right side. You just have to play with it a little bit more. So that is the normal distribution.